Hi, Ravindra.
Hi.
Yeah. So, Ravindra, the panel name is Swatantrata. He will be taking your interview.
Okay.
So, please be online. He's just going to join, okay?
Okay, sure, no problem.
Hi Neha. Hi Veera.
Hi, good afternoon.
Very good afternoon, Veera. Sorry for being late.
Yeah, not an issue.
With Teams, okay?
Okay, yeah.
Yeah, Veera, please introduce yourself.
Sure, yeah. This is Veera. I have overall 12 years of experience completely on Java. And from last couple of years, mostly working on the Spring Boot microservices, cloud technologies like AWS, majority into AWS, and some part of experience on the Azure and Google Cloud as well. And I do have a good experience on the distributed microservices and distributed Redis cache, and also good experience on these event-driven microservice architecture, and also good experience on handling the team and also designing and implementing the microservices.
Okay, sounds great, Veera. Can you explain me your previous project,
Right.
Veera?
Yeah. So the previous project I was working for basically, the payroll company was Variety and working for basically the Dell. So that application, it's basically monitoring the internal systems. Let's say it's basically that product will be given for the customers as a free of cost. Just added just a new feature for the customers. So let's say we have a systems or servers. They wanted to monitor all these servers, whether the servers are running or not, and how much memory is consumed. So what is the applications, the health check. So everything will be given as a, dashboards, and also we will be producing some kind of a reports. So it was purely implemented with the Java. And most of the part was implemented on the Java side. So we were only fixing the bugs, and a lot of changes on the infrastructure side. So that is what we have done. So when I say the infrastructure side, so basically that product will be supported. Initially it was only for the IPv4 version, whereas we wanted to support for IPv6 as well. So when we say IPv6, so the pattern for the IPv6 is completely different. So we have a couple of changes on the Java side, but the majority changes on the infrastructure side, because how we are going to run the services, and how we are going to build it on the client VMs. So because the client might be using, let's say, it may be CentOS or Ubuntu, so we need to support all the different operating system. So those are the changes, mostly we have done on the, the infra side.
Okay, got it, Veera. So here in the previous project, you were contributing as an individual contributor
Yeah, so I
or
can say no offshore.
managing.
Yeah, I was handling the offshore side, and we have a person at onshore. So mostly I was working on the development and also the designing perspective in terms of the IPv6 migration.
Okay, sure. So going through your experience, you have 12 years of experience, and I see in my mail is for Java developer. So
Yeah.
just
Okay.
wanted to understand like, what kind of
Okay.
session we need to have.
Okay. Okay.
Okay,
Yeah.
right, Veera. Okay, is this your first round, right?
Yeah. Yeah. This is the first round. Yeah.
Okay, then let's run through some basic Java discussions, right?
Right. Yeah.
So, what version of Java you had used, Veera?
Yeah, I have used up to Java 1.8, and recently I explored all the latest versions, but not hands-on. But I'm very much comfortable on Java 1.8.
1.8, right? So,
Right.
on Java 1.8, what was so much interesting? What was the great feature that you feel
Right. So the
they
major
introduced?
features, which completely, kind of revelation in Java version. So the Stream API and the functional programming is the main feature. And along with the
Mhm.
functional programming, so we also need to have lambdas, whereas to process the data. So I mean, it basically optimizes the code and all. So
Mhm.
mostly I can say the Stream API, lambdas, functional programming. So these are the major features. We do have some minor features like Java optional changes. It's not so great feature, but still, the way we write a code in before Java 7, before Java 8. So how we are checking the null, and also it has some predefined method, whereas we no need to have a null check. So we can use whether is present or if present methods. And also we do have some changes on the I think even threading also. Yeah.
Mhm. Okay, so when you say functional programming, right?
Right.
So you're referring to functional interfaces,
Yes,
is
functional
it?
interfaces. Yeah. So
So,
basically,
what
yeah.
functional interfaces are? Why do you think it has created a
Right.
revolution in Java 8?
Right. Yeah. So before Java, I mean, not we do have many programming languages. So which basically supports both object oriented and the functional programming. So when we say object oriented and functional programming, so let's say I wanted to access some behavior. So I want to call some method. So we basically before Java 1.8, so we create a object and then we call a method. So it's a basically purely the object oriented programming. Whereas the functional programming, so we no need to create an object for, we no need to have a separate implementation for our interfaces. So we can directly provide the anonymous implementation using the functional programming. So we can directly, call that particular functional behavior from the interface itself. So we no need to have a separate object for it. So that's the basically the that is where we use the functional interfaces. In order to achieve that, we should not have a more than one abstraction in the interface, because the compiler doesn't understand so which particular method that we are going to implement, because we don't need to define so which method we are going to call. So just write them in the curly brackets and what parameters that we wanted to pass it. So we don't need to worry about what is the method name that we are going to call, because it has only one abstraction. So, and even before Java 8 also, we do have a anonymous functions. So anonymous function, let's say I want to have a runnable run method. I wanted to override a run method. So we don't need to write implements runnable and again, override the run method. So we can just write new, the runnable, and then write the anonymous function as a run method. So that was optimized in Java 8 using the functional programming.
All right, okay,
Yeah.
got it. And yeah, so what is the difference between abstraction and interface? What is the main difference?
Right. Yeah.
Earlier about the abstraction methods and so on. So
Okay.
why we have a separately abstract class and why we have separately interface?
Right. Yeah. So basically, as we know, Java doesn't support the multiple inheritance. To achieve that, basically we have a interfaces. So let's say I wanted to have a I wanted to achieve the multiple inheritance. So when I say the multiple inheritance, one class cannot extend multiple classes, right? So we can extend only one class. So if I want to have let's say a class A extends a B and C, B and C has the same method. So when we try to extend, the compiler doesn't understand so which method we have to override. So whereas in interfaces, so it basically avoids the multiple inheritance issue by implementing the interface. By implementing the multiple interfaces. So in the override, when we try to override, we can define which particular interface method we are going to override. So that is one of the thing. Other thing, basically abstract classes, it doesn't provide the pure abstraction. When I say the pure abstraction, it has the abstractions as well as the concrete behavior. Whereas in interface, before Java 8, it was a pure abstraction in interfaces. Even from Java 8 also, even though we write a default methods, still the interfaces provides a pure abstraction.
All right, yeah, fine, Vira.
Yeah.
So do you know about solid design principles, Vira?
Yes.
Can you explain?
Yeah. So we basically in the software, the designing and development cycle. So we fall. I mean, most of the people follows the solid principles, but we may not, call them. So basically, we have a single responsibility. So when I say the single responsibility, so the class should not have a more than one responsibility. So if I'm going to, it may not be a class. Let's say I'm going to have an interface. So interface better we can have only one responsibility, so that in future, let's say I wanted to, make some changes in the interface, right? So let's say if the interface has more than one implementation, so it is going to be tough to change the implementations. So that is the single responsibility. And we have a open closed principle. So basically the software programming, the program that we write, it should be open for extension and closed for the modification. So let's say I'm writing some program, so we should be able to extend it, but the behavior, I mean, let's say there is some other function which is going to call, so that should not have any direct impact for that. So only we should be able to extend it. Let's say I wanted to have a the another overload method or anything, so we should be able to override it. So similarly we have the Lisco substitution principle. I mean, I don't exactly remember the internal principles. So basically one is the interfaces and inheritance features. These are all the basically the OOPS concepts that we follow while implementing any programming.
Okay, right, Vira.
Yeah.
So, in design patterns, like what all design patterns you have commonly used in your previous projects?
Yeah, mostly used. We have a strategy pattern, factory, and even facade and a builder pattern. So nowadays, builder we use it with the Lombok itself. And a singleton, anyway, I'm aware of the singleton. I mean, we have not used in the recent projects, but we used in the earlier projects.
Okay, so builder pattern, why do you use?
Right. Yeah. So builder pattern, let's say I have a class whereas it has hundreds of variables. So I wanted to have, let's say I want to create a constructor instead of setter getter. I want to go in a constructor fashion so that so while creating an object itself, I can pass the parameters. So I can pass the values. So whereas in the builder pattern, so it's a similar to the constructor. So let's say I want to have some of the default parameters. Always I should construct it, and the remaining parameters are optional. So let's say we have a ID, name, let's say salary and age parameter and mobile number. So let's say so maybe the salary I'm not going to enter in all the cases. Assume that. So if, whenever is required, then then only I'm going to build that particular variable, other parameter. Otherwise, I'm not going to build it. So what we are going to use is in the builder pattern. So in case of Lombok, we it comes with the default is it doesn't have anything. So let's say we have a employee class, employee.build.builder, new builder, and then whatever the the variables that we wanted to set it, we can set it. Whereas our customized builder pattern, so what we do is we create again the static class, whereas we are going to have a build method in the build and again the constructor in the constructor. So if at all we wanted to pass any default parameters, we can pass it, and the remaining thing we just going to have the 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 setters and getters. So whereas we are going to set those parameters only.
Okay, so why do you use a facade pattern, Vira?
Yeah, facade I don't exactly remember. Yeah, it's been very long back I have used.
Okay, strategy pattern.
Yeah, strategy pattern. So one of the gaming applications. So what we have done is we have two different microservices, whereas both the microservices consumes the same feed, and so one application is basically to process the feed, another application basically to calculate the score. So the initial steps, I mean, the collecting the feed and all is a common for both the services. So instead of having two different services all together, I mean writing the same functionality duplicate, so what we have done is we have implemented a strategy. So based on the instance or the I mean based on the instance, which particular service has to be invoked. So let's say when we get the type as the scoreboard, so we are going to invoke it, so only the scoreboard functionality. So let's say when it is a regular field, so we are going to call the the other service which we have. So that is where we have used the strategy. Hello.
Yeah, got it.
Yeah.
So you said you had used distributed caching, right? So
Right.
what about local caching, Vira?
Yeah, we also
You
used
have any requirements have
yes,
local
yeah,
caching?
yeah. So basically, I mean, I have implemented a couple of the microservices. So what basically, most of the services we used Redis as a distributed cache. Also, we used in-memory cache. So basically, what happens is in the, as I mentioned, the gaming application. So the event, assume that we have a cricket. So when the cricket match is started, let's say the event might end for 2 hours or 3 hours. So definitely there should be some limitation. If it is a one-day matches, I don't know exactly matches. It may be 1 to 24 hours. So that should end. So after 24 hours, I may not require the data. So what we do is, let's say when the match is started, every match will have some event ID in technically when we talk about it. So when we get a feed continuously, let's say the overs are going on, so we definitely get a score and how many balls, lot of other information from the feed provider. So when we receive that, so for every time we receive it, we are going to get as an event ID. So event ID and other feed details. So now I wanted to store somewhere, or I wanted to send it to some feed systems, or let's say some bed systems. So who is going to use the as a bed provider? So now what happens is, so when the event is received, I wanted to calculate the scoring. So if I wanted to calculate the scoring, so assume that I'm just going to maintain only the distributed cache. So every time I need to make a call to the Redis and get that particular score and again do the calculation, with the previous score and the current score. So instead of that, assume that my containers are consistent and it is not stopping anything. So I can maintain the in-memory cache. Whereas instead of every time making a call to Redis and getting the score, so what we do is whenever we make a call, we parallelly write the cache into the in-memory cache and Redis cache. When we make a get call, basically we are going to calculate directly from the in-memory cache. Let's say if the in-memory cache is not available, there could be a scenario. So maybe the server is rebalanced. So what we do is again we make a call to the Redis and again we sync into our in-memory cache. So that is where we use the distributed cache. Basically to avoid much more calls to the, it may be database or it may be an API or it may be some external systems.
So when you're talking about in-memory cache, like what is the structure you had followed?
Yes.
For what type of cache it is?
Yeah. It's basically the key value pair. It's a simple map we have taken. So the concurrent hash map. So it will be stored inside the the container itself. So since we use the Docker containers, so the memory will be stored inside the containers itself. So whenever, let's say it's a rebalance or any system is crashed, any VM is crashed, and I mean VM in the sense container is crashed. So again, we make a call to the Redis and then we do the synchronization between the in-memory and Redis again.
Okay, so if you are using concurrent hash map,
right,
and say you have 1 lakh records,
right,
cache entries.
Yeah.
So you're doing that in concurrent hash map, 1 lakh records as well?
It's basically the event IDs, based on the event IDs. So we will not have a much event IDs basically here. So let's say hardly.
You don't understand. Then what will you be doing with this kind of scenario?
Okay.
You have 1 lakh records in.
Yeah. So basically, we should have a proper indexing. So when we have a more number of, huge data, it may not be a good practice to have the data into the in-memory cache. The reason is, when we are storing in a single container or a single VM, the large number of data inside the in the in-memory cache, what happens is our VM will be sufficient only for the maintaining the cache. So we cannot, the server cannot take more number of requests to process it. I mean, that's not the good practice to have it. The cache main purpose is, so when to maintain a minimal data and to respond in a faster. Once our purpose is solved, so definitely we have to remove the data from the cache. If there is such a scenario, definitely I would say we can go with any non-relational data structure or anything.
But non-relational data structure also is not kind of a cache, right? So we
Yeah,
will have
not a
latencies.
cache. Yeah, still, but in terms of the performance wise, so it is somewhat better. Because we cannot have a millions of records in the in-memory cache within one container. So
you are correct. So, but you need to have caching. Okay, local caching you need to have, so that we don't have latency issues, and you have a continuous inflow of data.
Okay.
So
and and how much time we wanted to maintain the cache? Do we have any limitation? I mean, just
so you have those strategies, right? I mean, time to live strategies and a cache return.
Right. Exactly.
So how we are going to basically, I'm asking about least recently used cache, such kind of cache. How we are going to implement a least recently used cache in your application?
Yeah, basically we are going to have a indexing, and as you mentioned, the least recent used one will be in the top of the. The data will be populated in the first of the in the indexes, and every data that we are going to write in the in memory has to be indexed. so that it will be properly aligned, and we can have a inside again the caching. We will have, we can have a logically partitioning, so that grouping or partitioning. So based on the group, so I mean, I'm just assuming, so based on the group, it might be a good idea to fetch it faster.
Okay. So how do you evict the cache? I mean, the older data.
Yeah. So there are two things. So we can, based on the event, we can evict. Another thing, based on the time. So the data when we write into the map, so we have to define the time when it was written in the cache. So based on the time, so we have map.remove. So we can pass that particular event ID, because when we cache it, so particular event will be in a single logical unit internally. So that entire unit can be evicted. So that is one thing. In case of distributed cache, we have a evict method in the Redis template. So using the evict template also we can evict it. Other thing in the Redis, so evict policy, when we define while writing the key into the Redis itself in the configuration, we provide the eviction policy. Basically the time to leave, how much time we wanted to keep that into the cache.
Okay. Right. So far, like in your past experience, have you, in any of your projects, like, was there a kind of a real time, data and real time performance issues? Maybe this kind of issues usually happen on retail domains or a banking applications where the calculations are very intensive and the response times are very very stringent.
Right. Yeah. So yeah, this application also, as I mentioned, the previous application, the feeding gaming feed application. So it's a basically highly intensive. So that particular application operated in basically Europe and Australia. So what happens is, when the data arrives into the system, so that has to go to the the real time dashboards within a fraction of seconds. So sometimes we see the performance issues when we receive a feed. We are the integration layer, whereas we process and then we finally send it to the bed systems. So when the data arrives into our system, we are going to log it. So what is the time we received it? When we are going to send the data to the bed systems, again we are going to log it. So let's say the feed provider or the feed receiver, they says that we have sent the data correctly, and the data which is populated in the dashboards, there is a huge gap or delay. So we have seen this kind of issues. So how we analyze is, so when we received it, we calculate the time, and again for every microservice, what is the time duration it is taking, and again let's say we have sent it to the bed systems. So let's say again, even they will have their own processing logic to send it to the dashboards again. So I mean, to consume from the dashboards again. So we again verify into their systems, and when it was received from their end, and we try to identify, there is one scenario, basically the bed receivers has a limitation. Every second they will accept only 30,000 requests per second. So if we are sending beyond 30,000 requests per second, so it is not going to accept it. So that was one of the scenario we faced it. So they took some time to implement that. I mean, basically their servers are legacy systems, they cannot scale. So later they implemented the auto scaling mechanism, so we could able to solve that.
Okay. Mhm. So what is that you guys try to look when you find a performance issue?
Right. Yeah. So there are two things. The first thing, definitely, as I mentioned, so we check the time, how much time it is taking. Second thing is whether that issue is in within our application, or could be some external systems. So if it is internal our application, so again we verify what is the, I mean, what is the issue with our code. So it may be some infinite loops, or unnecessary iterations we perform it, or unnecessary the validations or API calls. and also we try to implement a kind of a parallelism, so where we can process the multiple resources at a time. So that way, it's easier for us to resolve that issue. And what we have done is, that feeding a game feed application, so it was taking so long. So some of the things that we parallelized using the Spring Web Flux. So we try to use the thread resources effectively.
Okay. So what is this Spring Web Flux, Veera?
Yeah, it is basically the reactive programming. So we do have, I mean, generally people use in a olden days, so we use the threading. So now instead of threading, so we have a Spring Web Flex. It is a reactive Java programming. We do have a RX Java, I mean, very long back, and Spring Web Flex has come up with a solution. So where we can process, the multiple resources in parallel using the reactive Web Flex.
Okay. Can you explain the difference between mono and flux?
Yeah. So mono basically, we only, it will return only one object, whereas the flex is basically the stream of objects. So flex has, zero to many. So whereas mono has only a 0 to 1.
Okay. All right. Uh, can you explain me about circuit breaker stuff?
Yeah.
Have you
Yes,
implemented any
yeah, we used it
spaces?
in one of the application. It was long back, but I know. So circuit breaker basically it's one of the design pattern in the microservices. So let's say we have a lot of microservices are interconnected, or maybe one of the microservices which is not responding what we are expecting, or it might be throwing some exception. So there could be some scenarios where we wanted to have some kind of a default response to the user, so that user will not be interrupted. So what we can do is, we can have a circuit breaker pattern, nothing but we can implement a fallback scenario. So when we say the fallback, so instead of throwing an exception to the user, so we can call the fallback method or the fallback API, so which is going to return the default response. Even in one of the scoring related applications, so we have an external API which is going to not a scoring, the pricing related application, so which is going to return the pricing. Let's say when the pricing application is not available, so what we have done is not exactly the circuit breaker that we implemented. So we I mean, we verify for 3 times that API, 3 intervals. If it is still not available, we have a default jar file. It's a basically, the simple Java application it was implemented. So we calculate the default pricing. So that is also similar to the circuit breaker. And also I implemented the circuit breaker using the Hystrix fallback.
Okay. All right. So, what ID you had used, Veera?
Sorry?
ID.
Oh, IDE. Yeah, I used both IntelliJ and STS Eclipse.
Okay.
But from
All
last
right.
couple of years, mostly using on IntelliJ because it's very faster.
Okay. And are you aware of the ACID properties in
Uh,
terms of database?
yeah, not much, but I can answer.
Yeah, please go ahead.
Yeah, so basically, in terms of the database transactions, so let's say we do have a couple of databases we wanted to perform the transactions. So we let's say I wanted to commit the data. So if it is within the transaction, I mean within the table, so we directly perform the transactions. So you're talking about the propagations only, right? The asset transactions and the propagations only, right? I don't exactly
Yes.
remember. Yeah.
Yes.
Okay. Yeah. So we do have a different propagations. So let's say I have two different service layers or two different repositories. I want to call one repo to the different repo, nothing but to perform the. I want to save in first one repository. Once that is saved, I wanted to save into the again different table. So those kind of scenarios, we are going to use different propagation logics. Whereas the transactional the propagation requires in one of the repository, so that has to be supported in the different repository. So whereas we are going to write in the service layer at the rate transactional and the propagation supported, so that we will be able to perform the transactional between the two different tables or the repositories. I mean, we do have other propagations as well.
Okay. All right. So you had used NoSQL DBs also?
Yes, I have used Mongo and DynamoDB extensively, and I do have some experience on the Cassandra.
Okay. What is the main advantages of going using the NoSQL DBs, Avira?
Yeah. So as we know, the no SQL, it's a basically the no structure query languages. Basically, it doesn't have any structure, and it's a highly scalable because it is not the connections wise. Yeah, when we see the relational databases are the connection oriented. So when we launch a particular database instance in the relational, so let's say that particular database instance might support, let's say, 1,000 connections or 10,000 connections or something like that. Whereas the non-relational data store, it doesn't have any connections limitation. As much we have the memory, so the databases are highly scalable and it doesn't maintain any structure. Let's say first I'm going to get a JSON document which I wanted to store into the non-relational data store. So we no need to worry about which column that we are storing it. So it is just the collection or the document that we store into the non-relational data structures. And different non-relational database has a different limitations in terms of storing the JSON documents as well.
So in your perspective, which one is more faster, RDBMS or
Yeah, generally
NoSQL?
non-relational databases are faster. I mean, if we are performing any joins and all, relationals, if you are not performing any joins and all, both relational and the non-relational are same. If wanted to perform any joins and all, definitely relational databases are not, definitely it degrade the performance. Whereas in non-relational databases, we will not have any kind of a joins and all. I think Mongo it was introduced, but I have not worked on. So we can have a two different APIs, or we can store the entire JSON document to entire JSON object into the single document.
Okay. All right. So in the messaging system, which one have used, Vira?
Yeah, I have used Kafka, Apache Kafka, and even Confident Kafka also.
So you used to produce and consume the messages
Yes,
from your
both the
microservices?
producers and consumers. And
I mean,
even
you used to do that from your microservices?
yes, yeah. Basically, to implement the event-driven microservices, assume that I wanted to send the feed. It could be any retail data or even the gaming feed or whatever. So we are going to use the producers which will send the data to the Kafka cluster into the topic. So the consumers which are going to continuously monitor the topics and get the data from the consume the data from the topics. So every topic will have it logically divided into the partitions. So the partitions are meant for basically distributing the data between the different consumers. Let's say I have a 5 partitions. I can have a 5 different consumers. Who is going to consume the feed parallelly. And so let's say if one of the consumer goes down, so the data will be distributed among the remaining consumers. So once the data is consumed and processed it, so in a batch wise or every message that we received it, we can commit those offsets into the topic. So once we receive once we commit the offsets, we have a different set of configurations. Let's say I wanted to, my application is down and again it is up. So whether I wanted to consume from the beginning or consume from the last committed offset or consume the latest, we have auto offset reset property, so which is going to decide how we wanted to consume when the systems are restarted.
Okay, all right. So you had used Kafka and not RabbitMQ.
RabbitMQ, I know little bit we used for, there is a cloud bus refresh in the Spring Cloud configuration server.
Okay, okay, no issues, sir.
Yeah.
You should be. Okay, you're talking about bus refresh, right?
Yes.
So what is that mainly, used for?
Yeah, bus refresh basically, assume that I have a lot of microservices. I wanted to change some of the configurations. Maybe it could be some valid values that I wanted to add into the configurations. So we can keep all those configurations into the centralized configuration server. Whenever we make any changes, so I don't want to restart my services. I just wanted to have a refresh. So we do have a general refresh in the actuators. So that refresh will work only for one microservice, whatever that we are going to refresh it. Whereas the bus refresh, all the microservices will be connected to the any of the RabbitMQ or Kafka. So basically, when we post, I mean, when we send click on that post bus refresh, so that event will be triggered to all the microservices, and the services which are referring the configurations, it is going to refresh. All the microservices are going to refresh. Basically, that event will be broadcasted to the all the microservices.
All right, okay. Oh, okay. With respect to cloud, you have worked on Azure, is it?
Mostly AWS. I do have some experience on Azure, but not much. There is something called what is it? We facial detection. There is a AI related API that we consumed it.
No issues. So when you're deploying your microservices,
Right.
so how you're what is your deployment strategy?
Yeah. So basically, yeah, there are a lot of things. So we do the containerization. So basically, every microservice will have a Dockerized services. So when we have a Docker file during the build creation in the Jenkins, so it is going to create an artifact and create an image, and that particular image will be published into any of the container registries. It may be a Docker or Nexus or JFrog repository or anything. So once the images are published into the centralized repositories, so our pipeline is going to trigger. So our pipeline also triggers from the Jenkins. So from the Jenkins, what we do is when we define a particular environment, which particular environment we are going to run it. So it is going to get a specific manifest, and in the backend we have a Terraform script which is going to create a couple of things. One is the task creation. So that's into the AWS, the container service, ECS. So we do have a lot of, couple of things again in the ECS. We do have a Forget cluster, ECS with the EC2, ECS with EC2, Windows and Linux. There are a couple of things. So it is going to create a task. The task is nothing but the configurations which is required to, to set up our application. Let's say my application want to run it in 9092 port. So what port and what configurations that we wanted to pass, and how much memory is required to run our application, and how many CPUs we need. So all these configurations will be part of the task configuration. Once the task is created, we are going to have a service. In the service, what is the load balancer, and what is the how many instances that we wanted to run, what is the auto scaling policy, and how many designed instances. So all the set of configurations we are going to have it in our service. So once the task is created and then we need to run the service, so the service will execute our the container. It's basically internally it is going to run with the Docker run, and it will run in the Elastic Container Services. Hello.
Yeah. Okay.
Yeah.
So in your, are you familiar with this Jenkins pipeline script writing and all, or you had a separate team for that?
Basically, Terraform script, Ansible script and all, we used to make changes, but not from the scratch anytime. So whenever there are any issues or we wanted to introduce something new, so I used to make changes.
Okay. So you were using Jenkins, not GitLab, right?
No, Jenkins only for the build purpose. GitLab build, no, we have not used it. But in some of the projects, we used GitLab only for the code check-ins.
Code repository. Okay.
Yeah.
All right. So you're not using Kubernetes
No,
EKS
I do
cluster?
have experience on Kubernetes in one of the application.
Okay, what is the difference between Docker containers and Kubernetes?
Right. Yeah, Docker containers are and Kubernetes are completely different. So Docker is, we just say it's a containerization. So whereas what, let's say I want to run my Java application. So what is required to run my Java application? So we need to have a Java environment. Let's say if it has to run it in server, we need to have a server, and what configurations is required, where we wanted to store all the logs, all the set of configurations we are going to write in the Docker. So the Docker runs in any VM. So it may be in Windows or Linux or any operating system. Whereas the containers, Kubernetes, we say it is the orchestration. So let's say I want to run my application with 10 different parts. It's nothing but 10 different instances, similar to that. So we are going to use the Kubernetes, with the kubectl commands basically to run it. So Kubernetes again, with Kubernetes, we are going to use the Helm chart to apply all these configurations. And we do have a couple of things in the Kubernetes. Our services will run on a namespace. We have to define which namespace we wanted to run our service. What is the service name? What is the deployment strategy? And all these auto scaling configurations that we are going to configure in the Kubernetes the deployment files.
Okay. All right. All right, Veera, that's all I
Yeah,
had.
yeah.
Any
Okay.
questions for me?
Yeah, just want to understand. So, what kind of the project and the requirements that you're looking for here?
Uh, Not really sure on the
Okay.
the requirement. Veera, actually,
Okay.
Encora, you might be knowing, it's a service-based company. Okay.
Right. Right. Yeah.
So panel, we are from a different project, and your hiring is for a different project. So project
Oh.
name is Trustwave.
Okay.
Could be that. I think that is a new client, I believe.
Okay. Okay.
For Encora.
Okay. Understand.
Yeah, and if it is a new client, then obviously the tech stack and all will be
Yeah.
the
Yeah.
latest
Exactly.
tech stacks.
Right. Okay.
Yeah, so there is, I think, since there is no panel from Trustwave,
Okay.
looks like it's a project that Encora is signed up for with Trustwave.
Oh. Okay. Okay. Understand. Yeah. Okay.
Right, we're nice talking to
Yeah.
you.
Me
Huh?
too. Yeah. Thank you so much. Bye. Have a good day. Yeah.
Have a good day.